Hello, I'm Dave Rubenstein, Editor-in-Chief of SD Times, and once again, I'd like to welcome you to today's program, Modern Infrastructure with NoSQL and Containers. Should be a good one. Before we get started, I have a couple of quick announcements. First, today's program will be followed by a live Q&A. You can ask a question at any time during the presentation. And we will get to as many as time allows during the broadcast. Secondly, today's program will be available on demand on sdtimes.com probably within the next day or so, and you can listen to it over and over again on demand to your heart's content. Okay, so as we've been reporting in SD Times, containers are an efficient way to deploy and scale applications. Today's program, sponsored by NoSQL database provider Couchbase, will look at the benefits of running NoSQL on containers. So joining us today are Arun Gupta. He's Vice President of Developer Advocacy at Couchbase. Arun has been building developer communities for more than 10 years at Sun, Oracle, and Red Hat. And in fact, he led the engineering teams at Sun and is a founding member of the Java EE team. Also with us today is Ray Tsang. Ray is developer advocate for the Google Cloud Platform. He has extensive hands-on systems integration experience. And before that, he specialized in middleware, big data, and PaaS products during his time at Red Hat. Okay, so now to get the ball rolling, I'm pleased to turn it over to Arun Gupta. Arun, take it away.
Thank you. Thank you, David, for the introduction. Good morning, good afternoon, good evening, wherever you are. My name is Arun Gupta, and as David said, I run the developer advocacy team here at Couchbase. And I'm really excited to be here with Ray Tsang, who I've known for a few years. He's a good friend of mine, and we hope to work together someday. So the topic today is modern infrastructure with containers and NoSQL. In terms of containers, there's a lot of container frameworks that are floating around. The one that we're going to be focusing today on is Kubernetes, and I will let Ray do the honor of introducing Kubernetes later in the game. And in terms of NoSQL, again, there are lots of different ways of how you build your applications using NoSQL, and what we're going to be using is Couchbase. So essentially, if you think about it, we will talk about how can you build your applications using these two platforms. As I said, my name is Arun Gupta. You can easily reach me at my email address, arun.gupta@couchbase.com, or just like everybody, I have a Twitter handle as well. So let's start with what is Couchbase. Well, Couchbase is a distributed operational database. It's a NoSQL document database. It's fully open source. It provides all the tools that you need to build your applications with agility and operate at any scale. And we'll dig into each of these pieces a little bit more. But if you think at it, NoSQL, in terms of Couchbase, it offers you one solution that spans your entire application horizon for any database needs. Whether you want to run as a managed cache as opposed to buying a separate standalone solution, you can use it as a key value store where you can have a key and a value could be whatever you want as a JSON document. You can use it as a persistence store where you can store JSON documents. On those JSON documents, then you can query them using a SQL-like syntax we call as NCL. So you can not only have a managed cache, a key value, but then backended by a persistent store, which is typically not the norm. If you look at the NoSQL database market, you would have a separate key value store or a cache, and then a separate document store, and then you will merge them into one. Again, another unique value proposition of Couchbase is an embedded database. You can run Couchbase in your data center, in the cloud, in the containers. That is for your enterprise needs. But if you want to run Couchbase in a mobile application, we have Couchbase Lite. And that allows you to run Couchbase in a variety of mobile devices. And then the magic glue that puts them together is a sync management, where you can say my embedded database is fully synchronized with my backend server. So in that sense, Couchbase provides you a full stack database from your backend database server to your database in the mobile device, and a synchronization capability between the two. Let's talk a little bit about develop with agility part of it. There are lots of pieces, on how customers and developers are building agile applications these days. We provide you a easier and faster development cycle over here. You can easily build your applications. We have a variety of SDK programming languages, Java, Node, .NET, Go, Ruby, all sorts of programming languages that you can use to build applications with Couchbase. Couchbase being a NoSQL document database, it gives you the ability for flexible data modeling. You are no longer confined to the rigid structure that is required by a database. That really allows you to evolve the application a lot more rapidly. In addition to a JSON document being stored, we also provide you the capability for powerful querying on top of it. So as I said, you can say select star from your bucket, which is where all the documents are stored. You can query from that bucket using a SQL-like syntax. There are support for where clause, join, nest, unnest, and it's a full CRUD capability. You can not only just select, but you can create, update, delete, all of those capabilities as well using those query languages. We provide integration with lots of the, actually most of the major tools for integration and migration, all sorts of integration with big data tools like Spark, Hadoop, Kafka, Storm. All of those integrations are baked into the product itself. And then last but not the least, you can run Couchbase on edge devices, whether it's a mobile phone, whether it's a Raspberry Pi, or whether it's some other BeagleBoard. And we have the ability to run it on those edge devices, and that is being fully synchronized. So lots of ways by which you can use Couchbase for running your applications. In terms of operate at any scale, Couchbase has a homogeneous architecture which allows you to scale it very easily. So you literally start one Couchbase node, then you add another node to it, and that node becomes part of the cluster. So that really makes it simple and easy on how you scale it, whether it's running on-premise or it's running in your Amazon or it's running in your own data center, works very well. And the beauty of this is the performance is consistently high, independent of how it is being scaled. You get a consistent high performance across your application. It also provides you the ability to do multi-data center, so you can set up Couchbase clusters. Of course, Couchbase can be set up in a cluster very easily, but you can set up Couchbase cluster very easily across different geographies, and then those clusters can be easily replicated, what we call as cross data center application. So you can easily set up a cross data center application for high availability and disaster recovery very easily. Those functionalities are baked into the product itself. It comes with enterprise-grade security, so you have support for RBAC or role-based access control, and there are some simple and very powerful administration tools, either using REST API or using CLI or using your web interface. In terms of Couchbase Developer, now if you are a Couchbase developer, we integrate with all of the major frameworks as I talked about earlier. There are a variety of languages, as you can see on the top right of this circle. Then there are a variety of frameworks. It's very baked in into Spring Data and .NET and Link. It supports a variety of mobile platforms and runs on all sorts of different operating systems that you care about. It runs on all variety of cloud. Today, of course, we'll be focusing more on the Google Cloud and the Kubernetes container framework. One of the things I want to highlight about Couchbase, which is going to be relevant when we go later in the presentation, is a single node architecture. And why is it important? Now, each Couchbase server node has the following components as you see on the screen. It has a data service, a query service, and an index service. These are sort of the three key parts of any Couchbase server node. Now, in addition, in the most recent release, we have also released a full text search service, which is a service that you can enable. And in addition, there are multiple layers of software that exist over there. Now, each Couchbase server node exactly carries these capabilities or these services. And so the way Couchbase cluster really works is you start a node, you start another node, you start another node. All nodes exactly identical. You pick one node, and you take the other two nodes and add to the first node, which basically makes it as a cluster. Now, in order to automate it, in order to simplify the process, as you will see later today in this presentation, we have this concept of a master and a worker. That is purely from the automation perspective, and from the scripting perspective, this concept of master and worker is there. But there is nothing as a single point of failure or a single point of control from master and worker, which is unlike a traditional master-slave architecture. So this is only done to make sure that we have a single node that is identifiable where we can add it to. We could have picked up any node randomly as a master and everybody else is a worker. But once the cluster is created, it's a homogeneous cluster. The client can make a request to any of the nodes, and it will get the response back right away. With that, I will pass it on to Ray, who will talk about Google Cloud Platform, Kubernetes, and how we can run Couchbase in an easy way on the Kubernetes platform.
All right. Thanks, Arun. Yeah, would you be able to pass the control back to me?
I'm going to change the presenter, and I am going to...
Okay.
Okay.
I think I'm on.
Yeah.
All right, fantastic. Thanks, Arun. So very happy to be here today as well. My name is Ray. I'm a developer advocate for the Google Cloud Platform. And one of the things I love to do is to bring some of the latest and greatest technology that Google has to offer and Google Cloud has to offer to developers all over the world. And I love to hear about your experiences and your feedback about the session or about the technology. So please contact me also on Twitter @Satanism. And very briefly about Google Cloud, it is a service that's provided by Google, where we are, providing resources such as platform as a service, infrastructure as a service. If you want to deploy just your application, you can deploy it in our platform as a service, for example, where you just need to worry about the code, or you can get access to the raw virtual machines, and you can install basically anything that you like as well. So take a look at cloud.google.com to learn more about other offerings like storage and big data and machine learning services. But today I want to focus on the piece where it's about containers and container orchestration. At Google, just about all the services that we have, anything that you can kind of think about, like search or YouTube, these kind of online services were running in containers. In fact, we launch over 2 billion containers per week. And so we actually have a lot of experiences in orchestrating and managing containers ourselves. And the way it works at Google is that we actually have our container packaging formats, for example, but we have open sourced the fundamental container technology called C Group to the Linux kernel almost 10 years ago, I think, in 2007. And that C Group is the technology that's used to help you isolate the computing resources that you can use per process or per application, for example. So as a developer in Google, when we want to deploy an application into our infrastructure, this is internal view of what we actually do, is that rather than addressing each of the machines and say, hey, this is .1 or .2, we address all of the machines almost as a single cluster. So if you think back on how most of the enterprise architecture work today, is that at the beginning of the project, we would need to say how many machines do we need, and each of the machines will probably have a name. And when the machine is actually here, that's in the data center and racked and cabled up, we have to install specific operating systems. We have to install specific libraries and packages, and finally the application or the database, whatever that you want, you have to configure it specifically. And what we're doing a lot today is to morph an existing machine into an environment where we can run a single application. And so what happened then is we have to spend a lot of time doing these sequential steps. Usually there's a run book where you have to do these setups one by one, or you script it, but you still morphing the machine into the environment that you want to run. And if you do need to repurpose the machine to do something else, well, you probably will need to go back and see what's actually on there and remove the things and reinstall the things that's necessary for another application to use it. So at Google, this is what we actually do instead. Like I said, rather than addressing each individual machines and morphing them into what we need, at a high level, this is what we do. If we need to deploy an application like Hello World, we will write a descriptor like the one I'm showing you right now, and this will describe how we want to deploy the application. And rather than, again, specifying individual machines, we can specify like a cell. A cell is actually just a name for a cluster. So in a single cell or a single cluster of machines, we can address up to, it is composed of up to, like, say, 10,000 machines. Okay. And so for this application, we're just going to say we're going to run it in this cluster of machines. I don't really care which one. And this is the application we want to run. And this is the arguments that I want to give to this application. But more importantly, we can also isolate the resource requirements for this particular process. So we can say how much RAM, how much disk, and how much CPU this process can use. And now all of a sudden we are able to potentially run multiple processes on the same machines, but still being restricted to these type of resource constraints. And then we can say how many instances of this app do we want to run. We can say we need 5 instances. We call them replicas, right? And if we need more, then we can simply adjust the number of replicas to, say, 10,000. And our schedulers, our orchestration tool internally will then go out and, very quickly spin up, hopefully to this number of instances of applications. So at a more graphical view, this is what we do. The binary file that we created at the Hello World application is stored in a central repository somewhere where all of the machines can get to. The config file that I just showed you will be pushed to, say, a master node. It's called the Borg master. That is the this internal system that we have. It's called Borg. So we can push the config file to Borg master, and then Borg master will see, oh, I need to run this application across multiple machines in the cluster, but let me consult with the scheduler to see which of the machines is actually available, right? Which machine has the resource to execute this application. And it's going to check with all the machines and say, hey, do you have enough resource to run this? If you do, then go ahead and pull down the application and start executing the app. And very quickly, you'll be able to see like these applications popping up in the different machines that we have in our cell in the cluster. Okay. So that's what we do internally. And Google actually has taken many of the experiences and learnings that we have had, and we started the open source project called Kubernetes, and it was actually worked on by the original engineers who also worked on Borg as well. So we're taking a lot of the container orchestration experiences that we had, and we're kind of creating this new project. It's fully open source. It's called Kubernetes. And what it does is that it is designed to orchestrate containers across multiple machines. Its main atomic unit it can manage is just containers, and it supports multiple cloud. Actually, it doesn't just work on Google Cloud Platform. It can also work on other cloud providers, and also in bare metal environments. So if you have your own data center, you can also run Kubernetes within your data center as well. And it's written in Go, so that it can actually run in many places. In fact, I actually run Kubernetes on my Raspberry Pi cluster as well, just for fun. And this slide, I always have to update it. The numbers are probably already outdated, but basically what this is showing is that the project is on version 1.3 right now, and it's got a very, very active community in terms of open source contributions and interaction with the community. So please check it out. The source code is also on GitHub. You can find it on kubernetes.io. Okay, and at a very high level, this is kind of how Kubernetes work as well. You can see that it's very similar to the previous slides, but this is just an illustration of a high-level illustration of how Kubernetes work behind the scenes as well. So rather than having, say, your application being like a static binary or just a binary by itself, what we're going to be able to orchestrate is containers, right? So with containers, we need to create a container image. Then you can push the container image into a central repository. Usually, this is called the image registry. And then we can also write a Kubernetes configuration file and use a command line tool to push it into the Kubernetes master node. And very similarly, it's going to check with the scheduler. The scheduler will then say, well, for this application that requires this much resource, which of the machines can I schedule the application to, so that the Kubernetes is doing the deployment for you in this case, rather than you picking the machine yourself. And once it picks the machine, then that machine will then download or pull down the container image and start running that application or the job. Okay, and at a very high level, this is like a very simplified view of what that configuration file may look like. The takeaway here is that you can specify the container image that you want to run, and then you can also specify the resource isolation levels. And there's a lot more that you can specify, but this is a very simplified view. And finally, you can also specify the number of instances or replicas that you want to run. So if you need to run 1 copy or 5 copies of your application, you can simply change the number of replicas. Okay. So one of the takeaways for myself is that with Kubernetes, through the view of Kubernetes, we're looking at the entire cluster as a single resource, a pool of resource basically. If you have a cluster with say 100 CPUs, but your application only needs 2, you can let Kubernetes to kind of find which of the 100 CPUs is supposed to, be used for executing or running your application. So let's see how this works in real life. So I'm gonna go back to my demo screen here, and I'm going to be running most of my demos on Google Container Engine, and it is one of the easiest way for you to, create a real container cluster that you can run in the cloud. In this case, this is running in Google Cloud Platform. And the way that you can create a cluster, basically go create a cluster, give it a name, and you can pick and choose where you want to run the cluster, and you can pick and choose the machine types and how many nodes, like say 3 nodes or 6 nodes. And when you're ready, you just click on create, and you have a cluster that's ready to go. And for my demo, I've already created a cluster. I have a cluster with 4 different nodes. So this is a visualization tool that was originally written by one of the Google engineer, Brendan Burns. And I added a few updates here where you can actually see that I have 4 different virtual machines here, right? Each one of these nodes is a virtual machine that's a Kubernetes worker node. Okay. And what I can do then is I can actually schedule or start deploy, like say, an application into this cluster. I'm going to start off with something fairly straightforward, and so that I can explain a few concepts before we jump into a Couchbase example. Okay. So there are many different ways you can deploy the application. You can do it from the command line. You can do it potentially from the GUI, but ultimately it's going to kind of generate a descriptor for you behind the scenes. So I have all of my deployment descriptors checked into my Git repository. So it's really nice because then I can kind of describe what my architecture should look like as a source code, and I can check it in so I can keep track of all the changes as well. So here is a YAML file that describes how I can deploy a very simple RESTful service. It's a hello world service. Basically, it's a REST endpoint where if you hit it, it's going to say hello to you. And in this deployment, basically, I'm saying that it has some labels, which I'll get into in a second. My important takeaway here is that I can say how many instances of this application do I want to run, and also the image I want to start. So this image is actually hosted in a public registry, so actually anyone can download this image and run it in their own cluster at this very moment. But you can also specify a private registry if you want, either the registry is hosted by yourself or another private registry that's being hosted on the cloud, like say on Google Cloud as well. Now, labels are important. Labels is actually one of the most important concepts here. You can label just about anything that you deploy, any resource that's within Kubernetes. Okay? And labels is basically just key value pairs. You can name the key however you want, and you can also have any type of value that you want. So for example, here I have the key value pair of app is equal to hello world service. Visualize is true, just so I can say that I want this to show up in my visualization tool. That's open source on GitHub as well. But you can add any label you want. For example, you can say version is equal to 1.0, right? Or you can say environment is equal to prod, or you can say conference is Couchbase webinar, for example, webinar, like that, right? So you can label these things however you want. And the benefit about labeling is that later you can actually go back to Kubernetes and ask, hey, what type of applications have I deployed that has such and such label? So you can go back and say, show me all of the application that's running with the app is equal to Hello World service. And that's a Couchbase webinar or whatever. So you can query Kubernetes with labels. So I'm going to go ahead and deploy this. So I'm going to say, from my command line, make this a little bit bigger. I'm going to say kubectl apply -f Hello World service deployment v1. Okay. And hopefully, if I refresh, there we go. I should be able to see that on my screen. I can very clearly see that my Hello World service is up and running. And so here are a few concepts that's very fundamental to Kubernetes that you have to take away. Number one is that the atomic unit that Kubernetes manages is called a pod. Okay, that's very important. So every one of these gray boxes is a pod. A pod is basically a collection of tightly coupled containers that needs to live and die together. But then some people will ask, what will qualify to be running inside of the same pod? Well, usually you probably just run one container in the pod. Okay, so in this case, the Hello World application is just one container, and it's being managed as a pod in Kubernetes. But if this application requires additional components, for example, if I need to export some metrics to a monitoring system per instance, then maybe I can run another application, another container alongside of my primary application, and they can still be running within the same pod. And what that means is that they share the same IP address, and they are also scheduled onto the same machines as well, so they can also share volumes in between the containers within the same pod. Okay. Another thing that you look here that you can see is that every single pod, every one of these gray boxes has a unique IP address. And that's important because that actually maps to how many of the applications work today. Every app that starts has a unique IP. And because these IP addresses are unique per pod, what that also means is that if they are running on the same machine, they will have their own IP addresses, and they don't have to worry about, say, port conflicts because they have their own IP. The other thing that you can take away here is that some of these pods, you can see that very clearly, the very first gray box here is running on the machine that ends with WKH, and the other one's actually being scheduled to another machine, SGVE. So Kubernetes has determined that these two machines should be used to run these two instances of the same application. And these applications can actually talk to each other via the pod IP as well. Now, if I need to scale the number of instances and say, wait a second, 2 instances is not enough, I need more, I can go ahead and say kubectl scale my deployment Hello World service, and I can say rather than 2, I'm going to do 4. Okay, and there you go. Now we have 4 instances, and they all have each individually a different IP address as well. Now, the other question that people usually ask is, well, if you have all of these different IPs, how do I actually get access to these applications, right? How do I expose them externally or internally so that people can connect to it? Well, there are multiple ways. One way is, of course, to connect to these IPs directly. But usually what we do is we would, in a traditional architecture, we would put a load balancer in the front. And load balancing is actually a first-class citizen concept in Kubernetes as well. So here I can actually create a service. It's called a service, by the way. So we can create a service in Kubernetes. What that essentially means is to create like a load balancer that will then be able to load balance the traffic for you across these multiple pods or multiple instances of your application. And a service will then create like a real IP address. It will be a stable IP address. In this case, the service is going to create like a cluster IP, and it's going to be able to route the traffic for you. So here I'm going to go ahead and do that. Hello world service.yaml. And that should create the box here in green, and that is my load balancer essentially. In Kubernetes, it's called a service. Okay. Now applications can talk through this internal IP address and start basically having their requests load balanced across these individual instances. So those are the very basic concepts of Kubernetes. And what that also means is that now I can describe my entire app in these YAML files or in these distributors, where I can also check into their source code repository, but I can reproduce my architecture, my environment extremely quickly and easily. So for example, because of the time, I'm going to go ahead and run a script. And this script has nothing but calling a few Kubernetes deployment calls to deploy my entire stack of application. Okay, so I'm going to go ahead and do that. I'm going to code turn up. And what this is going to do is to basically ask Kubernetes to deploy, in this case, MySQL and Redis guestbook service and the front end, and there are multiple microservices running here. And I'm using Redis and MySQL just because that's the demo that I already have. And now, if you look at the screen, you can see that I have the front end up and running with 2 instances. It's talking to the guestbook service. I have 2 instances, which is talking to MySQL because that's how it's going to store the data in this case. Yeah, and I can also scale individually any one of these microservices as well. So, for example, if I need more Hello World service, I can go ahead and scale that. If I need more guestbook service, I can go ahead and scale that instead. Now, one of the things that you notice is that most of these services, they have internal IP address. Okay, they start off with the 10.x.x.x range, and that's internal. That means that it's only accessible from within the internal network. However, for the UI, I really want to be able to access it from the external network as well. So what I can do is to specify a service that's called an external load balancer. And what that means is now I can actually go to this application and I can say, my name is Ray, and hello, Couchbase webinar, like that. And hopefully that will save it to my database. And there you go. And that works just fine. So that's basically how we can use Kubernetes to provision entire system, basically. So let me go ahead and destroy this cluster. I'm going to code the turn up. And that's a very, very cool feature as well. So if you are done with something, if you don't need it anymore, you can just say, Kubernetes, go ahead and remove them. And it's going to remove all of these instances. And it will just be gone. Actually, you know what? I think I code turn up again, so never mind. Let me show you, since I haven't destroyed my cluster, let me show you one more thing, which is very important in Kubernetes, which is the ability to do, say, a rolling update. So currently, my UI has just, it has the white background, right? So if somebody come along and say, wait a second, maybe our study shows that a different color could do better. So let me go ahead and change the background color, right? And what you typically would need to do is to then in Kubernetes is that you create a new container image with the new application with the new updates, okay? And then you can ask Kubernetes to do a rolling update of this application. So one of the easier way to do this interactively is via the command line. I can say kubectl edit my deployment hello works UI. I think that's what it's called. Yeah. And here you can see my descriptor, and I can go ahead and change, say, my labels to say 2.0, and I can change the version. So here is the image I'm using. So I'm going to be using another image, which has a newer version, which has a different background color. Now, as soon as I'm going to save this, watch the screen very carefully. I'm going to save. And what's going to happen is that Kubernetes will say, oh, okay, well, now I need to deploy the version 2.0 and replace 1.0. So it's going to take down one of the older instances of the application and then deploy the newer instance of the application basically one by one. And you can control how fast or how many of the instances you want to deploy at the same time. And then it's only going to, say, deploy the next version or the next instance and take down the existing instance when a newer instance is ready to serve. Okay, and all at the same time, the application should still be working. There you go. Hey, Vic. There you go. And this is doing basically a rolling update. And as soon as the load balancer kind of kicks in with a new instance, now I can actually see my screen with the newly updated background color. Okay. Now, sometimes, we could be wrong about what we are going to deploy into our environments, whether it's a bug or it didn't work out so well, right? So in the case where I do need to say, wait a second, you know what? This background color, I used a different shade of blue. It doesn't look so good. So maybe let me change it back, So I can do a rollback pretty easily. So I can go ahead and see kubectl rollout. I can see show a history. Oh, sorry, rollout. What was that? Rollout. Hold on a second. There we go. So I can do a rollout, history, deployment. There we go. Ooh. And then I can see a history of deployment that's for my front end. I can see that I deployed twice. The first one is my initial deployment, and the second one is where I did my update. Okay, and I can roll back to any of the revisions that's being kept track of, or I can just do a rollback, undo, deployment, hello world UI. I can do that. And what this is going to do is to, again, using a rolling update, there you go, and slowly, reverting my changes. So killing basically my newer version of the app and starting my previous version of the app. And at the same time, I can still go back to my application. And when this rolling update is done, I should be able to see our previous application. Okay. So this is a very basic introduction to Kubernetes, so you will. Now there you go. Now we have rolled back to my previous version. Pretty easy to do. Okay. So then how can we actually use this to, say, deploy Couchbase, right? And we can use very similar concepts. So I'm actually going to say turn down. So I'm going to delete all of these application instances. Now you can see them going away very quickly. So I'm taking down all of these application instances right now. But instead, I'm going to deploy Couchbase. And we can use the very same concept with the pod, with the services, and also using, say, a YAML file to describe how I want to deploy Couchbase with Kubernetes. And Arun and I actually hacked together to kind of, because I'm now a Couchbase expert, so I lean on Arun's expertise on how Couchbase works and how we can run this in Kubernetes. And and this is what we actually come up with. So here it's actually open source. Arun has the link somewhere. It's on his GitHub as well. But basically, we have a couple of YAML files here. So I'm going to go open up one of them very quickly. So here we have a Couchbase YAML file, which is a replication controller. What that means is that it's the resource where it's there to manage the number of instances of, say, Couchbase or pods that we need to have. So because of the way that we need to deploy in Kubernetes for Couchbase in this case, we are using a master worker paradigm. Well, that's because we need a way for the Couchbase worker to kind of discover an initial set of nodes that they can talk to so that they can discover the rest of the cluster, right? So here I have a master, Kubernetes master, Couchbase master descriptor. And all this is doing is that it's going to start one instance of Couchbase using Arun's Couchbase image, and it's a type of master. And at the same time, we're going to create a service so that we can talk to this master node. And again, this is an external service, so anybody on the internet are able to access it in this case, right? If you don't want that, you can just remove that, and that becomes an internal service. Okay, so we're going to go ahead and do this. Yeah,
I have a question here. Now, this is good, because we created this master and worker topology. Now, this is only to make sure that the worker nodes can be added to the master, but I think one point worth clarifying is, all of these nodes are homogeneous. This is the Couchbase cluster, but once the cluster is created, the client can talk to any node. There is no master-slave architecture here.
Right, yeah. This is only for a way to deploy that in Kubernetes, but yeah, absolutely. And once the master node, in this case, rather than calling master node, I'm just going to say the first node. How's that? Once the first node is up and running, then we can have the other worker nodes or the other nodes to join this very first node. Like Arun said, they're all homogeneous, so it doesn't matter which node you talk to first. But in this case, I need one node to start off with. Okay, and so now the first node is up and running. Have a service created here, I can actually go ahead and access it, right? So let me see. There you go. And Arun, what port does Couchbase run on? Is 8091? Is that right?
8091, yeah.
Yeah.
That's the standard administration port, yeah.
Okay. And here we go. Let me log in. Hopefully I remember the password that you said. so here, this is running live, by the way. This is not a pre-recorded webinar. This is live. So I'm going to go ahead and sign in. And there you go. We're in this very first Couchbase node. And you can see that there's one node that's running right now in the container inside of Kubernetes. Pretty cool, right? So why don't we go ahead and start a few other nodes to join this cluster. So for that, we have the these other YAML file. And if I scroll down a little bit, you're going to see that this is using exactly the same container image that we used for the first node, because like Arun said, these are homogeneous nodes. But the only difference is that when this node starts, we are asking this node to join the Couchbase master. Okay, and that's very important. And the way it joins is by using and referencing this Couchbase master service, which is again this box in green. And the beauty of Kubernetes is that you can actually expose these services rather than memorizing the IP addresses. You can give it the name, the DNS name. So when I created this new Couchbase master service, it actually creates a DNS name so that within other pods, I can use the DNS name to connect to this node. And that's exactly what this is referring to. This is actually using a DNS name here. Okay, so I'm going to...
I think one point worth highlighting here is we are using a DNS name. Behind the scenes, the pods that are running in the replication controller, the pods are ephemeral because they go up and down. But the fact that service is a uniquely identifiable IP address, that's what the other nodes can address to, as opposed to directly accessing the pod itself.
Yeah, fantastic. So now we have started the worker node here, and let's see the status here. So I can go ahead and see, for example, there we go. Logs. Let's see if this worker node came out pretty well. So you can see that, oh, there we go. So I can see the log. I can tell the standard output in this container very easily. I can see that it has been added to the server. So now if I go back to my server, oh, there you go. Oh, that's pretty cool. So you see that pending rebalance is number one. What do I need to do to join the cluster fully, Arun? I think I need to go ahead and rebalance the cluster.
Right. So what happened really is, as you were explaining how you set up a Couchbase cluster, you set up Couchbase nodes on multiple containers, and then once those containers have been joined together to form a cluster, that's the first step. So we have already done that. Now, in order to rebalance, there is a rebalance button that you see in the Couchbase web console that you can click on it, and in rebalancing, any data that is on one cluster, that is part of the cluster, will be redistributed across multiple nodes.
Yeah, very cool. So let's see if I can spin up two. That should work. So now I'm starting another Couchbase node, and that once that starts, you can see it here as well. So yeah, that's all pretty good. And then we can, if I want to, I can click on rebalance, and we'll rebalance the cluster, right? But
right.
But there's one issue here. I remember that when we first discussed about this, is that, well, what if you need to persist data to the disk, right? In this particular setup, we haven't really set up any persistent volumes. Oh, there you go. Did you see that? The second node just came up. There you go.
Yeah. And I think the point that you're mentioning is very important, because Couchbase, so far the Hello World microservices that you showed are all stateless containers, even though that is the preferred way of building your application. But databases by nature are stateful containers. So if a container dies, and if that pod goes away, the volume on that pod is no longer accessible to me. So I need something more persistent.
Right. And so for that, Kubernetes is really, really good at now, because we have a way to provision, say, volumes, what we call persistent volumes. So I'm going to go back to MySQL very briefly, just so I can use a simpler example here. With MySQL, I can say, I need to use a volume, and this volume can be in the cloud. So in this case, I'm using Google Cloud Platform, so I can just create a disk in the cloud. I can reference to this disk, and then I can then mount it to the path that I need for storing, say, my MySQL database data. In terms of Couchbase, I can do very, very similar things. So I'm just going to run this very quickly, and then I'll get into what I have just done. Here I can also, in Couchbase, we can also specify volume mount. So you can specify a disk you want to mount into where Couchbase is actually storing data. Now, one of the things that we have been using, which is called a deployment or replica set or replication controller, that we can specify these volumes very easily. However, here's one of the issues with using this construct, right? Basically, now I'm saying that this, for example, if Couchbase is using just one of the disks, if I need to scale out in a deployment or a replication controller perspective, right, it's going to try to mount the same disk if I have another instance, right? So in this particular case, each instance will be sharing the same disk, and that may not actually work out so well. Depends on the disk, whether they can be shared with multiple writes, and that may introduce a lot of contentions and whatever. It's probably not a recommended way to say run multiple database instances, right? So in Kubernetes 1.3, we have this new construct which is called pet set. What pet set does is that it's very similar to what we have been doing before, except that the volume mounts, these volumes can be dynamically provisioned. What that means is that I can start off with one Couchbase node, for example, that has its own disk. If I scale out the number of Couchbase nodes, then we can actually, if we're running a cloud environment, we can actually automatically create a new disk in the cloud and then registering that within Kubernetes and then mounting it to the new instance of that application. So now I have two Couchbase instances, and basically what happens behind the scenes is we will be able to provision two different disks and then mounting it individually into each one of these Couchbase containers or Couchbase pods, okay? Which is really, really nice and powerful. So let's see this in action as well. So again, Ron and I work on this a little bit, where we used we created what we call Couchbase pet set. Okay. So the construct is another YAML file. The construct is very similar, except that on the top we said this is a pet set. And again, the construct is very similar in terms of we need to run a container. Okay. And the only difference is that we need to mount the volumes into where Couchbase is storing data. And remember where we need to know that very first node that Couchbase is running on so that the other newer nodes knows how to join it? Well, with a pet set, what we can do is that every instance of the application gets a predictable DNS name as well. So the first instance is always going to be Couchbase-0 in this case. The second instance will be Couchbase-1 and -2 and -3 and so on and so forth. So rather than having, say, the master worker paradigm that we used previously, now we just always know that the first node is -0, and that's the node that we need to connect to register ourselves. Okay, so that's one of the ways to do that. And then we can ask Kubernetes to dynamically provision some of the disk that I need for this instance to use. And in this case, I'm saying that I need, for each one of these instances, I need a storage of 1 GB that's mounted to OPT Couchbase var. So let me go ahead and apply this. I'm going to do a kubectl apply. Well, first of all, I'm going to do create a service. Okay, and then I'm going to apply the pet set. Crossing my fingers. Okay, there you go. And let me just make this a little smaller. There we go. Get pause. Okay. So now you see that we have another Couchbase instance up and running, but this is using pet set. And what's happening behind the scenes is that it's going to create a new disk for me so that it can be mounted directly into this Couchbase instance. And that may take a little time. And there you go. I think I have replica set to 2, so now I'm having two instances here. If I look into the persistent volumes, what we call PV, persistent volume, I can see that we have a persistent volume for Couchbase 0 instance, and then we have another persistent volume for Couchbase 1 instance. And if I need to scale out, for example, what I can do is, let me go here. I think I have a patch coming in here. So I can do a kubectl patch. Oh, there we go. The Couchbase patch set. And then I can say I need, rather than 2 instances, I need 3 instances. I'm going to go ahead and do that. And if I come back to my screen and say get pod, I can now see 2 instances. The third instance is going to be up and running. And if I see PV, remember we only had 2 before? We only had 2 1 gigabyte disks, and now we have 3. That's because the newer one is being automatically created in this case to let the instance consume. Okay. So let me see if I can get access to this service as well. So I can go to the kubectl UI, and let's see how this works. So there we go. There we go, administrator, and hopefully I can get in just fine. Yeah, perfect. And if I see the server nodes, you can see that there are, again, 2 servers waiting to join the cluster. That's because we have a total of 3 pods running for my Couchbase. So that's I think a very brief introduction and a view into how you can utilize Kubernetes to provision your application workload and also stateful workload and NoSQL workload such as Couchbase. So Arun, anything else that you may want to cover? So one last thing I just want to say is that Google Container Engine is what I use for today's demo. And there are many different ways you can run Kubernetes. You can run it on your local laptop with Minikube, or you can run in the cloud. In fact, you can run in different cloud providers as well. If you use Vagrant, we have many scripts for you to get started as well. So give it a try.
Yeah. Thank you, Ray. I think this is fantastic. It exactly shows how you can run Couchbase and then Kubernetes in a scalable way. Most importantly, it's very well integrated with the Kubernetes primitives itself. So you can use kubectl to scale the number of replicas, and the containers are automatically started, and you can scale it up, scale it down using kubectl, and Couchbase container automatically scales up. One of the questions, and we didn't get to show that today, was about, can I auto rebalance the cluster, as part of the configuration file? There is a parameter for that. Yes, we can do that, but the recommended strategy really is you add a bunch of nodes and then you rebalance, because rebalance could be a costly operation depending upon the amount of data that you have, because you're really rebalancing the buckets, all the JSON documents across multiple nodes. So add. So you scale first and manually rebalance, just from a design pattern to be aware of. But I think this is great. Let me see if there are any other questions here. The links to the presentation, yes, would be available. Yeah, I think those are all the questions at this point.
Excellent presentation, gentlemen. I would like to thank Arun Gupta, Vice President of Developer Advocacy for Couchbase, and Ray Zhang, Developer Advocate for the Google Cloud Platform, for today's presentation. And we certainly want to thank Couchbase for sponsoring this presentation today. And most of all, we'd like to thank you, the attendees, for hanging in there with us all day today. Thank you very much, and until next time, so long.